Welcome back, focused learners. Ready for another explainer? Today, we are completely transforming the way you look at the human body. Seriously, I want you to think of yourself not just as a student right now, but as an explorer, a cartographer, really. We're going to build the ultimate Mapmaker study guide to make absolutely sure you crush your upcoming anatomy exam. You see, by treating the human body as a landscape, with its own specific coordinates, borders, and laws, mastering this dense material actually becomes incredibly intuitive.
Okay, let's take a quick look at the syllabus so you know exactly the territory we're conquering today. We're hitting the big three definitions, navigating the human map, mapping the body cavities, and finally, the rules of homeostasis. Let's get right into it.
Section 1. The big three definitions, laying the foundation. Because hey, before we can read the map or even dream about charting a course through it, we need to understand the fundamental language of the land.
First up, we've got anatomy. Now, when you see this word pop up on your exam, I want you to instantly recall the root words. It comes from the Greek ana, meaning up, and tomi, meaning to cut. This is your pure cartography. It's the study of the physical structure, the specific locations, and the actual names of the body's parts. Basically, anatomy is the map itself.
Next, we move to physiology. This one is derived from the Latin physio for nature and logi for study. Think of it this way. If anatomy is the physical map, the roads, the cities, the bridges, then physiology is the action. It's the traffic, the weather. It's how all those intricate structures you just mapped out actually work and behave in nature. And then we have pathology, which brilliantly illustrates what happens when the map breaks down. It's rooted in the Greek word pathos, which translates to suffering or experience. So pathology is literally the study of disease. It's what happens when the structures of anatomy or the functions of physiology go wrong and ultimately cause the organism to suffer.
Moving on to Section 2, Navigating the Human Map, focusing on directional terms. Now that we've got our solid foundation of the big three definitions, let's figure out how to properly orient our compass.
So, here is a crucial, absolutely vital point. Every single direction on your exam assumes the body is in this exact stance. We call it the standard anatomical position. Take a really good look at the skeleton here. The body is standing upright, facing directly forward, arms are at the sides, and listen up, because this is where students constantly get tripped up. The palms and the toes are facing perfectly forward. This right here is your true north. Every directional term you learn is relative to this specific pose.
But you might be wondering, what if the body isn't standing? Well, let's look at two highly testable terms, prone versus supine. I've got a great little insider test prep trick for you here. The word supine has the word up in it if you scramble the letters, right? But an even better way to remember it is that you lie on your spine when you are supine. It literally means lying flat face up. This is the position that gives surgeons direct access to the face, neck, and torso. Prone, on the other hand, that puts you flat on your stomach face down, with your dorsal, or back, side facing up.
Let's project our compass onto a standing figure to really lock in your spatial awareness. We have superior, which means toward the top of the head, and inferior, pointing toward the bottom. If you move away from the midline of the body toward the outside edges, you're moving lateral. Conversely, moving toward the center is medial.
All right, here are 4 more essential compass directions. Definitely fire these off into your memory bank because these are highly testable favorites. Cranial is toward the head, while caudal is toward the tail end. And when we think about layers, deep means heading toward the very center of the body or an organ, while superficial brings you right back out toward the surface of the skin. Make sense? All right, Section 3, Mapping the Body Cavities, the Territories. With our compass perfectly calibrated, we're ready to divide our human map into specific physical zones.
Now, what is really interesting here is how clearly the body separates into 2 massive mega territories. On the left, we have the dorsal cavity. This runs right along the back and fiercely protects the central nervous system, so your brain and spinal cord. Then, on the right side, taking up the front of the body, is the ventral cavity. This massive space houses all your vital visceral organs, from your lungs and heart up in the thoracic cavity, all the way down to your stomach and intestines in the abdominopelvic cavity.
Because the abdominopelvic cavity is just so large, medical mapmakers divide it into a tic-tac-toe grid of 9 distinct regions. You'll want to mentally screenshot this checklist immediately. Seriously, matching these 9 regions to their anatomical locations is practically a guaranteed exam question. You've got your center column, epigastric up top, umbilical right in the middle, and hypogastric at the bottom. Then that center column is flanked by the hypochondriac, lumbar, and iliac regions on both the right and left sides.
Tying it all together visually, you can clearly see that tic-tac-toe board projected right onto the abdomen. Notice how the umbilical region perfectly centers around the navel? Your navel basically acts as the ultimate anatomical landmark. It anchors this whole grid so medical professionals can pinpoint exactly where a patient is experiencing pain. Whether it's way up in the right hypochondriac region near the liver or down low in the right iliac region near the appendix, this grid tells them exactly where to look.
Which brings us to Section 4, the rules of homeostasis. These are the laws of the land. Finally, let's explore the dynamic rules that keep this map incredibly stable, balanced, and, well, alive.
The big rule here is called homeostasis. Once again, let's break down the Greek to absolutely guarantee you remember it. Homo meaning same, and stasis meaning stand still. But here's the catch. Homeostasis isn't actually about standing perfectly still. It's your body's constant, highly active battle to maintain a stable internal environment. I'm talking about your core temperature, your blood pressure, your blood sugar. It fights to keep those stable even when the outside world is throwing extreme heat, freezing cold, or, I don't know, a massive Shuri donut at you.
So how exactly does the body enforce this law? Through feedback loops. When your exam inevitably asks for the mechanism of a feedback loop, these are the exact 3 sequential steps you need to write down. First, the receptor. That's the sensor that detects a change or an imbalance. Second, the control center, usually the brain, which receives that signal and determines the appropriate response. And third, the effector, the actual muscle or gland that executes the physical response to fix the problem.
Now, there are 2 different flavors of these loops, negative and positive. And the key difference you absolutely must remember for the test is their ultimate goal. A negative feedback loop counteracts and opposes a change to restore normal balance. It shuts the stimulus down. But a positive feedback loop, it does the exact opposite. It aggressively enhances and amplifies the triggering stimulus until a specific major event is completed.
Think of negative feedback literally like a seesaw. It's by far the most common mechanism in your body. Let's say the seesaw tilts up because your body temperature is rising on a super hot day. Your receptors sense it, your brain's control center processes it, and it tells your effectors, in this case your sweat glands, to produce sweat. The sweating cools you down, bringing that seesaw perfectly back to level. It completely opposes the heat, beautifully illustrating the return to homeostasis.
Positive feedback, on the other hand, is much rarer but incredibly powerful. Childbirth is the classic, most highly tested example of this. The baby's head presses on the cervix, acting as the initial stimulus. But this doesn't trigger the body to stop the pressure. Instead, it triggers the brain to release oxytocin, which causes even stronger uterine contractions. This pushes the baby harder, releasing more oxytocin, causing harder contractions. You get the idea. It's a rapid amplification loop that only breaks when the ultimate goal, delivery, is completely resolved.
As we wrap up this Mapmaker's guide, I want to leave you with a pretty crucial thought. If homeostasis is the ultimate law of the land, perfectly balancing our physiology within the strict borders of our anatomy, what on earth happens to our map when pathology steps in? How exactly does disease redraw those borders and completely override the control centers of everything we just learned? Keep that big question in mind as you study, and I promise these foundational concepts are really going to stick. Good luck on your exams, everyone, and keep exploring.